Hi everyone, I am Polash Kumar Bora. Today I will solve question paper of 2019 and it is a paper of Assam Higher Secondary Education Council. Already I have started solving questions of this paper and till now I have discussed questions of 1 mark. Here I will solve questions of more than 1 mark. Okay, before going to our main content, as before, I would like to share one interesting fact about one identity, and that is a plus b whole square is equal to a square plus twice ab plus b square. And everyone knows this actually, and it is a very familiar and common identity used by every one of us. Still, I would like to share. Many of you may be knowing the trick, but I feel like sharing that one. Okay, for this we have to consider one line segment, and let me consider one point over there, and the length before that point is suppose A, and length after that point is suppose B, and the overall length of the line segment is A plus B, and by taking help of that length, let me construct the square. Then the area of the square will be a plus b whole square, and let me keep aside that a plus b whole square. Now from the point, let me draw one vertical line, and also let me draw one horizontal line, as you can see in the figure. Okay, then sides with length are shown in the figure. Then the area of the small square, as you can see, it will be a square, and area of the bigger square inscribed in the circle is b square. And we have two rectangles, and the area of those two rectangles will be a into b. So from here we can say a plus b whole square is equal to a square, b square, and we have two rectangles of length ab, so it is twice ab. So we can say a plus b whole square is a square plus twice ab plus b square. Okay, because of this we have this identity. I hope you like it, and if you want to have more information of this type, then you can search in the YouTube. Many more videos you can have. Without wasting much of our time here, let us go to our main content. Okay, let us solve question number 2. And what is the question here? Let the mapping fx is equal to ax plus b, a greater than 0, maps close interval -1, 1 onto close interval 0, 2. Show that cot of cot inverse of 7 plus cot inverse of 8 plus cot inverse of 18, and this is equal to f of 2. Okay, before solving this problem, let me recall one of the result of inverse trigonometric function, and that is cot inverse of x plus cot inverse of y, and this is equal to cot inverse of xy minus 1 divided by x plus y. Okay, now in our problem the function is given to be f from close interval -1, 1 to close interval 0, 2, and this function is given to be onto function, and the function is defined as f of x, this is equal to ax plus b. So this function is of the form y is equal to mx plus c, and we know that this is nothing but the standard equation of a straight line. If a function is given to be onto, and onto function is going from close interval to close interval and is defined as a straight line, then always remember that f of extreme point of the function, extreme point of the domain must maps to extreme point of the codomain, and this is equal to 0, and extreme point 1 must maps to extreme point 2 of the codomain. This implies f of -1, if I put -1 here, it will be minus a plus b, so this is equal to 0, This implies we can write A is equal to B. This implies A plus B, this is equal to 2. Now therefore A plus B, in place of B I can put A here. A, this is equal to 2. This implies twice A is equal to 2. This implies A is equal to 1. If A is 1, then B is also 1. Fine. Up to here I think no one is having any problem. Okay. Now let me consider cot inverse of 7 plus cot inverse of 8, and this is equal to cot inverse of 7 into 8 minus 1 divided by 7 plus 8. If I use this formula, then I have this one. So this is equal to cot inverse of 7 into 8 is 56 minus 1, it becomes 55, divided by 7 plus 8 is 15. So 5 is a common factor, so I can divide by 5. It will become 11 and it is becoming 3. So this is equal to cot inverse of 11 by 3. Therefore cot inverse of 7 plus cot inverse of 8 plus cot inverse of 18, and in place of this I can put cot inverse of 11 by 3 plus cot inverse of 18. Again, if I use the formula of this cot inverse of x plus cot inverse of y, then I have cot inverse of 11 by 3 into 8 minus 1 divided by 3 plus 18. So this is equal to this 6 cot inverse of, this one is becoming 65, and it is 11 plus 54 by 3. So this is equal to cot inverse of 65 into 3 by 65. So I have cot inverse of 3 here. Okay. Left hand side. Left hand side is equal to cot of cot inverse of 7 plus cot inverse of 8 plus cot inverse of 18, and this is equal to cot of, and this is found out to be cot inverse of 3. So this is equal to 3. Okay, now you see fx is equal to ax plus b, as our the value of a and b are 1, so I can write f of x as x plus 1. So this implies if I'll be putting the value of x to be 2 here, then this is 2 plus 1, so it is 3. That means in place of 3 I can write f2. So this is equal to f2, and this is equal to right hand side. Okay, and this is our answer. Okay, now see the or part of question number 2. Find the value of cos inverse of x plus cos inverse of that part, and where x lies in between half and 1. So for this problem I will consider x to be cos theta, and let us see what will happen if I consider x is equal to cos theta. X is equal to cos theta. This implies cos inverse of x is equal to theta. Okay, therefore cos inverse of x plus cos inverse of half plus root 3 root over 1 minus x square. Sorry, here x is there. Okay. Okay. So this is equal to cos inverse of x. I can write theta plus cos inverse of half x is cos theta root over 3 1 minus cos square theta. Okay, so this is equal to theta plus cos inverse of half into cos theta root 3 by 2, and this is 1 minus cos square theta is sin square theta, and square root of sin square theta is sin theta. Okay, so this is equal to theta plus cos inverse of, in place of half I can write cos of pi by 3 cos theta, and root 3 by 2 I can write sine of pi by 3 sine theta. Okay, let me recall one result. Cos of x minus y, and this is equal to cos x cos y plus sin x sin y. This formula I'll be using it here is cos x cos y plus sin x sin y form. So I can write cos inverse of cos pi by 3 minus theta. Theta plus, if I use composition of function over here, this will become identity. So I of pi by 3 minus theta is pi by 3 minus theta. So this theta get cancel out, and this is equal to pi by 3, and this is our answer. I think it is not so difficult, a simple one. Okay, now let us talk about question number 3. Let f is a function going from real number to real number is defined by f of x is equal to thrice x minus 2, and g is again a function going from real number to real number is defined by g of x is equal to x plus 2 by 3. Show that f dot g is equal to g dot f. Okay, let me recall one result here. The result is f dot g is equal to g dot f if and only if f dot g of x is equal to g dot f of x. This is a result that needs to be understood by us to solve this problem. Now our function f is going from real number to real number, and it is defined by f of x is equal to thrice x minus 2, and g is a function going from again real number to real number, and it is defined by g of x is equal to x plus 2 by 3. Okay, first of all we will find f dot g of x, and from the composition of function this is equal to f of g of x. F of our gx is x plus 2 by 3, so this is equal to our fx is 3 something minus 2. Then you see if it is x, then whatever is here that is coming over here. Okay, so if it is x, it is x. If it is x plus 2 by 3, then it will be x plus 2 by 3. So this 3 get cancelled out. We have x plus 2 is equal to 2. Sorry, I did a mistake here. It's minus. So this is equal to x. Okay, fine. Now let me find g dot f of x. g dot f of x. And if I use the composition of function, again we have g of fx. So this is equal to g of fx is thrice x minus 2. So this is equal to something plus 2 by 3. You see, if it is x, it is x. If it is thrice x minus 2, then this will be thrice x minus 2. So this is equal to this minus 2 plus 2 get cancelled out. It is thrice x by 3. So again 3 get cancelled out. We have x here. Okay. So from these two, I can say f dot g of x is equal to g dot f of x. Therefore, f dot g of x is equal to g dot f of x. This implies, now, as we have the result, f dot g of x is equal to g dot f of x implies f of g is equal to, sorry, f dot g is equal to g dot f. So I can write f dot g is equal to g dot f. Hence, we have the answer here. Okay. Okay, question number 4. It is a problem of determinant. And to solve this problem, we will proceed from left hand side and try to obtain right hand side. Left hand side is equal to, we will apply some elementary transformation to obtain the result. So first I will apply R1 goes to R1 plus R2 plus R3. Then we have this plus this one plus this one will give us a plus b plus c. This plus this also give us a plus b plus c. This and this will also give us a plus b plus c. Okay, and rest of the rows will remain the same as we have not applied any transformation over row 2 and row 3. Okay, fine. Now if you observe the first row, a plus b plus c is a common entry, so that I can take it as common. If I take that as common quantity, then we are left with 1 1 and 1, and the rest of the rows will remain the same. Okay, and now I will apply column transformation here. Now how this column transformation is taken, now you see here. Applying C1 goes to C1 minus C2, and C2 goes to, suppose, C2 minus C3. And let us see what will happen. This is not only the transformation, even you can take different transformation, no problem is over there. This is only one the part. You can take different approach also, no problem is there. So this is equal to, sorry, a plus b plus c is already there. Sorry, is 0. This minus this will give us a plus b plus c. This minus this will 0. This minus this, it will be 0. This minus this will be minus a minus b minus c. This minus this will be a plus b plus c. This one is 1 twice b, It is C minus A minus B. Sorry. If you observe the first column, A plus B plus C can be taken as common quantity, as this can be written as 0 into A plus B plus C. This can also be written as 0 into A plus B plus C. From here I can say A plus B plus C is the common entry or common factor for the first column. So that can be taken as common. If you observe the second column, from there also I can take A plus B plus C as a common quantity. So we are left with 0, 1, 0, 0, minus 1, 1, 1, twice B, C minus A minus B. Sorry. So this is equal to A plus B plus C whole cube. Now I'll be going for this expansion of this determinant. Okay, it's better you expand along that row or column which consists of maximum number of zero entries. Now, if you observe, first column consists of two zeros, first row is also consisting of two zeros. So I'll be taking the first row to expand this determinant, but you can take first column also, second column also, third column, there is no problem. But if it consists of maximum number of zeros, then our expansion becomes a little bit easier to handle. So I will be going by the expansion of the first row, then 0 into something, 0 into some determinant that I will not write, then again 0 into some determinant that is also not required to write. I'll just consider the third entry of the first row. So 1 into, now you have to form the determinant by eliminating the row and column consisting the entry 1. This will be eliminated, this will also be eliminated. So we are left with 1, minus 1, 0, 1. So this is equal to A plus B plus C whole cube. If I expand this determinant, so 1 into 1 is 1 minus 0. So this is equal to A plus B plus C whole cube, and this is equal to right hand side. Okay, fine. That is the answer of this problem. Okay, question number 4 or part. Okay, without expanding, show that this determinant is equal to 0. Okay, let us consider left hand side as it is. As you can see here, I'm considering left hand side, and first of all I will break this square. Then I have a to the power twice x plus 2 plus a to the power minus twice x, and this will be a to the power twice x minus 2 plus a to the power minus twice x. Similarly, the rest also you can break it. It will be okay. After that, I'll be applying some elementary transformation here. Applying C1 goes to C1 minus C2, then what will happen? Let us see. This is equal to this minus this, it will be 0. This minus minus 2, it will be plus 4, and this minus this will be 0. So it will be a to the power twice x minus 2. This will also be 4. Also be 4. Okay. From the first column I can take 4 common, and from the third column I can take 2 common. Then we are left with 1 1 1. This will also be 1 1 1, and this part will come over here, this part will come over here, and this part will come over here. We are not concerned about that. Okay, no problem is there. Now if you observe first column and the third column, they're the same. Now we have one property of determinant, that if any two rows or columns of a determinant are same or identical, then the value of the determinant is equal to 0. So this is equal to 8 into 0, so this becomes 0, is equal to right hand side, and that is our answer. Okay, very simple. I think just you have to remember all the properties of determinant, and if you can remember all the properties of determinant, then solving the problems of determinant becomes very easy. So okay, let me consider question number 5. Show that the function f defined by f of x is equal to modulus of 1 minus x plus modulus of x, where x belongs to R, that means it is a real number, is a continuous function. Okay, how to solve this problem? You see, suppose g of x, and this is equal to 1 minus x plus modulus of x, and okay, sorry, hx, this is equal to modulus of x. Okay, I'll just try to find h dot g of x. This is equal to h of zx from the definition of composition of two functions. Okay, so this is equal to h of gx means 1 minus x plus modulus of x. So this is equal to h of x means modulus of x. In place of x we have 1 minus x plus modulus of x, so it becomes 1 minus x plus modulus of x, and this is equal to fx. Now to show fx is continuous is equivalent to show h dot g of x is continuous, and we'll try to show that h dot g of x is continuous function. Now our hx, this is equal to modulus of x, so this is a continuous function, this is continuous. Now let me see gx as 1 minus x plus modulus of x. This is already continuous. Okay, we have already seen here. Now this one, you see, this is a polynomial function, and every polynomial function is continuous in R, so this is also continuous. Okay, now sum of two continuous function is again continuous, so we can say gx is continuous. And one more result is there, that composition of two continuous function is again continuous. We have already considered that fx is h dot g of x, as this one is continuous, this is also continuous, so we can say this is continuous in R. Okay, so we can say fx is continuous, and so this is our answer. Okay, let us now consider our part of question number 5. Discuss the applicability of Rolle's theorem to the function f of x is equal to x squared plus 1 on closed interval minus 2 comma 2. Okay, if you want to solve this problem, obviously we need to know what is the statement of Rolle's theorem, and you can see this is the statement of Rolle's theorem. If a real valued function f is continuous on closed interval AB, differentiable on open interval AB, and f of A is equal to f of B, then there is at least one C in between A and B such that f dash of C is equal to 0. Okay, that means if we want to check whether Rolle's theorem is applicable in our given function, we have to check all these three conditions one by one. Or let us see whether these three conditions are satisfied or not. Our fx is x square plus 1 is a polynomial function, and this polynomial function is defined on closed interval -2, 2, so it is continuous over there. So it is continuous on -2, 2. The first condition, condition number 2. Now if I go for finding f dash of x, it is twice x, and this is also defined in the open interval -2, 2, so it is differentiable. That means we can say it is differentiable on open interval this. Okay, third condition, we'll try to check whether f of -2 is equal to f of 2 or not. First let me find f of -2. This is equal to -2 whole square plus 1, so 2 square 4 plus 1 is 5, and f of 2, this is equal to 2 square plus 1, so 5. So from these two we can say f of -2 is equal to f of 2. So all the three conditions are satisfied, so we can say that Rolle's theorem is applicable over this function. Therefore we can say Rolle's theorem is applicable to the function f of x is equal to x square plus 1 on the closed interval -2, 2. Okay, that is our correct answer. Okay. Okay, let us consider question number 6. If y is equal to square root of e to the power square root of x, then find dy dx. Let me consider y is equal to square root of e to the power square root of x. This implies y square is equal to e to the power root over of x, so it is equal to e to the power x to the power half. Okay, let me consider u is equal to x to the power half. If I take derivative with respect to x, then we have half x to the power half minus 1, so it becomes 1 by 2 into square root of x. Okay, fine, no problem up to here. Therefore our y square becomes e to the power root over x is x to the power half, so it is becoming e to the power u. If I take derivative of this with respect to u, then we have this e to the power u. So from here we can write twice y dy du, this is equal to e to the power u. So this implies we can say our dy du, this is equal to e to the power e to the power u divided by twice y. Okay, but we are asked to calculate dy dx. Therefore our dy dx is equal to, if I use chain rule here, then it will be dy du, then du dx. So this is equal to, just you have to substitute dy du is e to the power u divided by twice y, into du dx. Du dx is 1 by 2 into square root of x. So this is equal to e to the power u. U means x to the power half, so it is square root of x. 2 into 2 is 4. Our y is this, so I'll be replacing that into square root of x. So this is our dy dx. Okay. Okay, I will stop here. In my next video again I will be discussing another 5 to 6 questions. And if you have any queries, you can ask me, or even you can comment me in my comment section. And till then, keep yourself safe. At last, thank you for watching.